Now that we have set up a fixed-time signal-controlled intersection, we need to add additional controls to secure all potential conflicting movements that can run at the same time, such as pedestrian crossings, permissive left turns, and right turns on red. In other words, we need to define the right-of-way for all conflicting movements in the simulation so that vehicles and pedestrians will not collide. In VSIM, the right-of-way designation is modeled by priority rules. Priority rules can be applied to all situations where vehicles on different links and connectors should recognize each other. A priority rule consists of one stop line, shown in red, and one or more conflict markers, shown in green, that are associated with the stop line. The stop line represents the position where vehicles would typically wait when yielding to other vehicles in the real world. The conflict marker represents the position of conflict between vehicles. Depending on the current conditions at the conflict marker or markers, the stop line allows vehicles to either cross or not. Conditions to check at the conflict markers are the minimum headway, minimum gap time, and maximum speed. During the simulation, the current headway is calculated as the distance between the conflict marker, green bar, and the first vehicle approaching it. If the current headway is less than the minimum headway, the corresponding stop line stops any approaching vehicle. The current gap time, which is calculated every time step, is the time an approaching vehicle requires to reach the green bar if it continues to travel at its current speed. If the current gap time is less than the minimum gap time, the corresponding stop line stops any approaching vehicle. Only the vehicles that approach the conflict marker at a speed lower than the maximum speed will be considered by the headway condition. In order for a vehicle not to stop at the stop line, all the conditions at all the corresponding conflict markers need to be fulfilled. Therefore, using the default setting for illustration, the headway must be greater than 5 meters, and the gap time must be greater than 3 seconds for any approaching vehicle on the main road that is traveling at less than 180 kilometers an hour in order for the vehicle on the minor road to cross. Now, let's define priority rules that are necessary for a signalized intersection. First, priority rules need to be defined at the pedestrian crossings so that the turning vehicles will yield to pedestrians during the pedestrian phases. To create priority rules, select the Priority Rules icon on the toolbar. The Priority Rules icon is the icon with a triangle like a yield sign. To make it easy to see, we will switch to centerline view by pressing Ctrl-A so that we can see the background image in which we have added points and numbers to indicate where stop lines, red bars, and conflict markers, green bars, should be placed. Since the vehicle phase 4 and the pedestrian phase 104 can run at the same time, the left-turn vehicles on the south approach should yield to the pedestrians crossing in the north and south direction. Left-click to select the left-turn connector, and then right-click to place the stop line on the connector at the position of the red point near the red number 1. Like signal heads, stop lines can be placed on either links or connectors where vehicles stop to yield. Here, we placed it on the connector. Next, left-click to select the northbound pedestrian crosswalk, and then right-click to place the conflict marker on the link at the position of the green point near the green number 1. In the resulting dialog box, you can select if the stop line or conflict marker is to be placed on a single lane or stretched over all lanes of the link using the All Lanes option. You can also specify the vehicle classes to be affected by the stop line and conflict marker. The vehicle class designation of the stop line affects all the conflict markers that belong to that stop line. In order to define a stop line for a different set of vehicle classes, a separate priority rule must be created, and the new stop line is often placed at the same location. Using the Condition button, you can link the priority rule with the current state of a signal group. For example, by selecting Stop only if the stop signal group 104 shows green, vehicles would not yield to pedestrians queuing behind red signals or to pedestrians during flashing Don't Walk. Condition criteria is most often used for protected or permitted left turns at intersections where the priority rule is only active when the signal is in permissive mode. Typically, due to low speeds on pedestrian crossings, the minimum headway is the most relevant condition, while the minimum gap time is the most relevant condition for free-flow traffic. Therefore, we could leave the default gap time as is for this pedestrian crossing, but for our example we will set the minimum gap time of 0 seconds and the minimum headway of 32.8 feet or 10 meters to show that the gap time is not really necessary in this situation. The Look Beyond Red Signals option decides if vehicles located upstream of red signals are seen by the conflict marker or not. If unchecked, headway and gap time are only checked up to the signal head when the signal head is red. Press OK to confirm the setting. A green triangle shows up, and the distance between the conflict marker and the green triangle presents the minimum headway. Next, left-click to select the southbound pedestrian crosswalk, and then right-click to place the second conflict marker on the link at the position of the green point near to the green number 1. Again, use minimum gap time of 0 seconds and minimum headway of 32.8 feet. If we switch to the normal view, we can see that 2 green bars are placed on each side of the left turn connector at the boundary where collisions with pedestrians may happen. Since the vehicle phase 2 and the pedestrian phase 102 can run at the same time, we will add another priority rule to control the right turn vehicles on the west approach so that they will yield to the pedestrian crossing in the east and west direction during the pedestrian phase. Left-click twice outside the network to initialize the process. Place the stop line on the right turn connector at the position of the red point near the red number 3. Place 2 conflict markers on the eastbound and westbound pedestrian crosswalks respectively at the positions of the green points near the green number 3s. A priority rule is also needed for the permissive left turn on the east approach. The left turn vehicles shall yield to the eastbound through traffic and the pedestrian crossing in the east and west direction. Left-click to select the left turn connector and right-click to place the stop line on the connector at the position of the red point near to the red number 4. Then, place the first conflict marker on the eastbound through connector at the position of the green point near to the green number 4. Use the default minimum gap time of 3 seconds and minimum headway of 16.4 feet or 5 meters. In this case, the minimum gap time is the most relevant condition. If there is more than one lane to cross, you may add 1 more second to the minimum gap time for each additional lane to cross. Next, place 2 more conflict markers on the eastbound and westbound pedestrian crosswalks respectively at the positions of the green points near to the green numbers 3. Set the minimum gap time of 0 seconds and the minimum headway of 32.8 feet. If we switch to the normal view, it is easier to see that the red bar is placed at a position where the left turn connector and the westbound through connector overlaps, and the green bars are placed on each side of the left turn connector at about the last positions where collisions between the left turn vehicles and pedestrians or through vehicles in the opposite direction may happen. If you right-click in an empty area of the network, it brings up a list of defined priority rules. You can select any priority rule to modify the setting or delete from there. If you select a red bar, all green bars associated with this red bar are highlighted. If you select a green bar, the corresponding red bar is highlighted, and a green triangle shows up and indicates the minimum headway distance set for this green bar. You can select and move a red bar or a green bar to any other position of different links or connectors. Delete a green bar by dragging it off of the link or connector, or delete a priority rule completely by dragging a red bar off the link or connector. If the right turn on red is allowed at the intersection, more priority rules need to be defined. For example, the right turn on red vehicles on the south approach shall yield to the eastbound through vehicles and the pedestrians crossing in the east and west direction. To allow the right turn on red, signal heads need to be configured differently, and stop signs need to be added at the intersection using the option Only on Red. In that case, the stop sign is active only if the associated signal controller phase displays red. To place a stop sign, first select the stop sign icon on the toolbar. The stop sign icon is the one with the white word STOP shown in a red octagon. There are two scenarios where the right turn on red can be modeled. First, if it is an exclusive right turn lane, like on the south approach, a stop sign needs to be placed on that lane, either on the link upstream of the connector or directly on the connector. Here, we can simply left-click to select the right turn connector and then right-click to place the stop sign on the connector at its upstream end. In the resulting dialog box, you can set the lane number and exact position where the stop sign is placed. Click on the second tab RTOR, Right Turn on Red, and select Only on Red. The stop sign is then active only if the selected signal group SG or the selected signal controller SC displays red. When the stop sign is active, vehicles are forced to stop for at least one time step regardless of the presence of conflicting traffic. For this stop sign, we link it to signal group 4 of signal controller 1, since signal group 4 is used for the through movement associated with this right turn. From the third tab, Time Distribution, you can set a dwell time distribution to replicate longer waiting times. We will discuss this option later. Click OK to confirm. Since this is an exclusive right turn lane, the signal head should be removed or disabled. However, it is advisable to keep the signal head on this lane and associate it to a vehicle class such as tram or pedestrian, so that the normal vehicles on the lane will not be affected by it, but the state of the signal will be visible. The second scenario of the right turn on red is a combination of through and right turn lane, like on the west approach. In this case, a stop sign needs to be placed on the right turn connector so that only turning vehicles will see the stop sign. For this stop sign, we link it to the signal group 2 of the signal controller 1. Then, we need to move the existing signal head to a position on the link downstream of the right turn connector so that only through vehicles are controlled by this signal head. Now, let's add priority rules for the right turn on red. Left-click to select the right turn connector on the south approach, and right-click to place the stop line at the position of the red point near to the red number 2. Then, place 2 conflict markers on the pedestrian crosswalks in the north and south direction at the positions of the green points near to the green numbers 2. And place the third conflict marker on the eastbound through connector at the position of the green line near to the green number 2. It is important to note that the conflict markers should never be placed downstream of the connector on which you place the red bar, because that may lead to a vehicle yielding to itself. To illustrate this, let's move the conflict marker downstream. You will see that 2 green triangles show up and cover both approaches leading up to the conflict marker. Let's repeat the procedure to define the priority rule for the right turn on red on the west approach. Left-click to select the right turn connector and then the red bar already defined on that connector. place 2 more green bars at the positions of the green points near to the green number 3s on the pedestrian crosswalks in the north and south direction. Now let's start the simulation to see how it works. During the simulation, the conditions of priority rules are updated at every time step, and vehicles make decisions to cross or not accordingly. Besides simple applications here as to complement the signal control, priority rules can be used to model stop-controlled intersections, roundabouts, keep clear areas, and any user-defined yielding. In VSIM, an alternative to priority rules to define the right-of-way is conflict areas. Conflict areas are easier to define and can be used in most cases for standard yielding. A conflict area exists wherever 2 links or connectors overlap in the network, including crossing, merging, or branching. For each conflict area, you can specify which of the conflicting links has the right-of-way. The right-of-way designation is illustrated in different colors. Green means the right-of-way, red means to yield, and yellow means the conflict area is passive, which has no influence on vehicles. There are 4 parameters that affect vehicle behaviors at conflict areas. Visibility defines the maximum distance from where an approaching vehicle can see vehicles on the other approach. Front gap is the time that a yielding vehicle allows before entering the conflict area after the vehicle with right-of-way has left it. Rear gap is the time that a yielding vehicle must provide after it has left the conflict area before a vehicle with right-of-way enters it. Safety distance factor determines the minimum headway that a vehicle on the minor road must provide when it is completely inside the merging conflict area. The driver behavior at conflict areas is also more intelligent than priority rules. Drivers on both the major and minor roads react to the conflict areas by making a plan to cross the conflict area in a way to provide the maximum possible flow rate for the minor road without influencing the traffic on the major road. Now let's go back to open the network file before priority rules were added. This time we will use conflict areas to secure all conflicting movements at this intersection. To define conflict areas, first select the conflict areas icon on the toolbar. Starting with the west approach, left-click on any position where the left turn connector and the southbound pedestrian crosswalk overlaps. The overlapping segments are displayed in yellow with the links outlined in yellow as well. This is referred to as a passive conflict area. If more than 2 links overlap at the position you checked, you can use the Tab key or the scroll button on the menu bar to select a desired pair of overlapping links. Then, right-click once or several times on the overlapping segments until the pedestrian crosswalk is displayed in green, which means it has the right-of-way. Repeat these steps to assign the right-of-way to the pedestrian crosswalk in the opposite direction. To control the right turn on red on the south approach, left-click at the position where the right turn connector and the eastbound pedestrian crosswalk overlap. Right-click to assign the right-of-way to the pedestrian crossing. Also assign the right-of-way to the pedestrian crossing in the opposite direction. Next, left-click at a position where the right turn connector and the eastbound through connector overlap, and right-click to assign the right-of-way to the through traffic. On the west approach, we will define a branching conflict area for the right turn from the through link and 4 conflict areas between the right turn connector and the pedestrian crosswalks. On the east approach, we will define a branching conflict area between the left turn and through connectors, a crossing conflict area between the left turn connector and the through connector in the opposite direction, and 2 conflict areas between the left turn connector and the pedestrian crosswalks. You can double-click a conflict area or right-click outside of the vSIM network to access the conflict areas dialog box. The conflict area you clicked is highlighted in the dialog box with the black marker indicated in front of the row. Here, you can edit the parameter or change the right-of-way designation for a pair of conflicting links. A double-click on a link number will set this link as the major road, shown in green, and the other link in this row will become the minor road, shown in red. You can also click a link number and select the appropriate option from the context menu. A conflict area can be switched to all red as a branching area by setting the green link of a row to yield. Setting a link to passive will completely disable a conflict area, shown in yellow. You can also select a row with a left click and delete this conflict area. The option Show All Possible Conflict Areas in Node provides a good way to check if any conflicts inside an intersection are not yet defined with an active area. To use this option, you will need to define nodes first. We will show how to do that later. Here, we already have Node 1 defined at this intersection. If it is selected, all possible conflict areas inside the node boundary will be listed, including all passive ones. Now, let's run the simulation to see how it works with conflict areas. Unsignalized intersections with one-way or two-way stop control can be easily modeled using stop signs and conflict areas or priority rules. Four-way stop control can only be modeled by priority rules using the gridlock resolution of the priority rules to prioritize the conflicting movements. Here, we will quickly show how to set up a one-way stop-controlled intersection at the lower left part of the network using the stop sign and conflict areas. First, place the stop sign on the westbound link at the position of the red line near the red number 1. Next, define a merging conflict area for right turn movements on the minor approach, then 2 crossing conflict areas and a merging conflict area for left turn movements on the minor approach. We will also define a crossing conflict area and a merging conflict area for the left turn movements on the major approach. It is also advisable to add branching conflict areas where vehicles of different movements split. In the current setup, vehicles will stop in front of the stop sign for at least one time step regardless of the presence of conflicting traffic. We can add dwell time distributions to replicate longer waiting times observed in the field. To create a dwell time distribution, select Base Data Distributions Dwell Time on the menu bar. In the resulting dialog box, select New to create a new dwell time distribution with 2 options, Empirical Distribution or Normal Distribution. A normal distribution is defined by the mean value and the standard deviation in seconds. Defining a standard deviation as 0 seconds results in a constant dwell time. If a negative dwell time is obtained from the normal distribution, it is automatically set to 0 seconds. Even if the dwell time is 0 seconds, for example a mean value of 0 seconds, a vehicle will still stop for one time step. Here we can set a mean value of 1 second and a standard deviation of 0.2 seconds. We can create another dwell time distribution of empirical type. It is similar to the definition of speed distributions by providing a minimum and maximum value and any number of intermediate points to build a graph of various shapes. In this graph, the horizontal axis depicts the dwell time, and the vertical axis depicts the cumulative percentage from 0 to 1. Let's create a time distribution with a minimum of 1 second, a maximum of 1.5 seconds, and an intermediate point at 1.2 seconds for 85%. Now we can assign dwell time distributions to the stop signs. Double-click to access the stop sign setting and then check Use Time Distribution under the tab Time Distribution. Click New to first assign the first dwell time distribution to vehicle class car, and then assign the second dwell time distribution to the vehicle class HGV. Let's run the simulation. Now, vehicles of the selected classes will stop for a certain time out of the corresponding time distribution in front of the stop sign.